Okay, for number 35, my least favorite question on the test. We're looking at an airplane leaving New York. They give us like different cruising altitudes, different speeds, things like that. Um, and there's a few components with this question. The phrasing was a little tricky here. It first starts with finding the speed of the plane, only at cruising altitude, in miles per minute. Um, so we start with cruising altitude right in that second to last line. Um, it's at the 192 mile mark, and then we go to the 762 mile mark. So once it reaches cruising altitude, it starts traveling for 570 miles. Okay, it was at 192 all the way to 762 is 570 total miles. Now, it took 32 minutes for it to reach cruising altitude, and then a grand total of 92 minutes. That's again why I don't like this question. There's a lot of weird terminology. Maybe like assuming you to know what like cruising and all the different terminology is for planes here. So it took you, or you were at cruising altitude, or this plane was at cruising altitude for 60 minutes. So that was pretty convenient because we are going to have to convert this, and we just simply have to divide. 570 miles in 60 minutes. What is that per minute? 9.5 miles per minute. So setting up a rate, we divide basically 570 by 60 to get our answer of 9.5. We did have to pull the 570 and 60 out, but through basic subtraction of finding how far we went and how long it actually took us. For part 2 here, this was the part that I thought was a little confusing. It said, write an equation to represent the number of miles the plane has flown during X minutes at cruising altitude only. So if we think of a linear equation here, we're modeling this. Our rate of change is 9.5. In other words, after every minute, we're going an additional 9.5 miles. So if X is our variable, the total number of miles we went during cruising altitude would simply be 9.5x. In other words, after 2 minutes, we've gone 19 miles and so forth. What some people tried to do for this part was compensate for all the stuff taking place in the beginning. So they added like y-intercepts and different values. Like I said, trying to make up for that 32 minutes and things like that. That was referenced in the beginning of the problem, but it was simply just 9.5x. And then it says, assuming that the plane maintains its speed, determine the total number of miles the plane has flown 2 hours into the flight. Okay, so 2 hours into the flight. First thing let's do, everything here was in terms of minutes. So that's the first little trick. Let's convert this 2 hours. How many minutes is 2 hours? If each hour is 60, 2 hours is 120 minutes. Okay, so right away we know that it took 32 minutes for it to go 192 miles. It didn't give us any information about when the plane was like initially taking off, like reaching that cruising altitude. We don't know like that big beginning component, but we know it took 32 minutes and it went 192 miles. So we're going to take away 32 from our 120 because we weren't going 2 straight hours at cruising altitude. It took us 32 minutes to reach that. So that's going to give us 88. So in other words, we're at full cruising altitude for 88 minutes. And now we can figure out how far we went during those 88 minutes by using our formula we got in part B, which would be 836. Okay, so we went 836 miles in cruising altitude. We went 192 miles earlier when we were reaching that cruising altitude. So that would give us a grand total of, if we add together both of these components, 1,028 total miles in 2 hours. So no part of this question was that crazy confusing, or I should say crazy complex and like doing some type of hard algebra skill, but some of the terminology was a little confusing with number 35, certainly. Everything was basically a little bit easier than what some people tried to make it. So this was number 35, 4-point question in part 3.